Welcome to myprojectbazaar.com. Project title: Dynamic Frequency Resource Allocation in Heterogeneous Cellular Networks. Let's see the abstract. In general, cellular network deployments are becoming saturated in areas with high density of users, such as in urban environments. Deployment of the low-power eco base stations within the cellular networks can potentially increase both capacity and coverage. However, such deployments require efficient frequency allocation schemes for managing interference from the pico and macro base stations that are located within each other's transmission range. Partitioning the available frequencies between the various base stations avoids the problem of the interferences, but it led to inefficient spectrum usage. Hence, in this project, I introduced a distributed frequency allocation scheme that shares the frequencies between the macro and the pico base stations, and it also guarantees a minimum average throughput to the users. The scheme seeks to minimize the total number of frequencies needed to honor the minimum throughput requirements. We evaluate our scheme using detailed simulations and show that it performs on par with the centralized optimum allocation. Moreover, this proposed scheme outperforms a static frequency resource scheme and the centralized optimal partitioning between the macro and the picos. Now see the flow of our project. First, the network is formed with the number of nodes, that is, it consists of the macro and the pico cells with separate base stations. This network have a set of FRBs, that is, frequency resource allocation blocks for allocating the resources for all base stations. Then it processes the dynamic allocation process. In this process, distributed algorithm is used to allocate the frequency blocks. If the constraints of the allocation process is validated, then it assigns the frequency resource block, that is FRB, to transfer the data. That is, it performs the data transmission. Else, if the constraints are not satisfied, it updates the FRB requirements and then it processes the allocation process. Finally, the performance is analyzed with its matrices. Now see the running procedure of our process. First, open the terminal window and go to the directory where we have the code. Then type ns space filename.tcl. Here 30 nodes are created and the exposition node position of all nodes are updated. Then the node information, that is, which node is communicate with the which node, that information is also written and updated in the terminal window. To see the output of simulation, this is the network animator window. Here only we see the output. These are the number of nodes. To run the simulation, click the play button. Here this is the simulation time, and we can speed up the process of simulation. Here the center, the macro base station is present and the pico base stations are present. The base stations have the number of nodes within its clusters are represented in separate colors. Here node 5 is the source node and 20 is the destination node. First, source node 5 communicates with pico base station and then it transfers to the macro base station. The macro base station will handle the entire cell. So it gives to the destination precursor destination and then in forward follows to the destination node. This is the process of the entire network. Here another source is created and it transforms to the pickup station. Like this the communication is processed. To see the performance results, back to the terminal window and type GNU plot graph name dot plot. This is a simulation graph for the packet delivery ratio. Here number of nodes is varied and the packet delivery ratio is calculated. The existing system have less packet delivery ratio than our system. This is represented in the variation of colors. Then to see another graph, type GNU plot graph name dot plot. This is a throughput graph. As same as the number of nodes are varied and I find out the throughput which is measured in the megabits per second, and the existing system have higher throughput than the proposed system have higher throughput than the existing system. Hence the overall performance is increased in our proposed system.